Good students. Our next topic is type of overlapping and nature of covalent bond. Types of overlapping and nature of covalent bond. Type of covalent bond and nature of type of overlapping of orbitals and nature of covalent bond. Here, the covalent bond may be classified into two types. One is depend upon the type of overlapping of orbitals. Overlapping of orbitals. Based on the overlapping of orbitals, covalent bond is two types. One is sigma bond, second one is pi bond. Sigma bond and second one is pi. Second one is pi bond. Means orbital overlapping depend on the covalent bond two types. One is sigma one and second one is pi one. Sigma indicating symbol of sigma and pi is pi. तो आपको तो पता है सिग्मा पाई का इंडिकेशन ये देते हैं. So how sigma bond will be formed and how pi bond will be formed. Sigma bond will be formed by the orbital overlapping of end-to-end overlap. Orbital end-to-end overlap होगा तो end-to-end overlap, end-to-end or head-to-head, head-to-head overlap और end-to-end overlap होगा तो orbital sigma bond form होगा. मतलब ये क्या होता है? Perpendicular to the internuclear axis. Internuclear axis पे ये दोनों orbital overlap होता है, end-to-end overlap होता है orbitals. So here, this type of covalent bond is formed by the end-to-end or head-on head overlapping of bonding orbitals, especially bonding orbitals important along the internuclear axis. And next, this is called head-on overlap or axis overlap. Internuclear axis जो axis पर रहेगा वही axis का end-to-end overlap. This can be formed by any one of the following types of combination of atomic orbitals. So head-to-head, end-to-end, head-on head or end-to-end overlap होगा. तो internuclear axis जो axis पे रहेगा वही axis पे orbital overlap. तो वो क्या होगा? सिग्मा बॉन्ड होगा. सिग्मा बॉन्ड टाइप्स यहाँ पे only between two orbitals. First one is SS overlapping. SS overlapping. Second one is SP overlapping. Third one is PP overlapping. SS overlap होगा तो कंपल्सरी ऑर्बिटल है, ऑर्बिटल ओवरलैपिंग. तो यहाँ पे ऑर्बिटल में टू टाइप्स ऑफ ऑर्बिटल्स है. वन इज s orbital, second one is p orbital. So here when s and p orbital overlaps, then here three types of sigma bond form होने के chances. Three types में ss overlapping, ss sigma bond, sp sigma bond and pp also sigma bond. p orbital overlapping, s orbital p orbital overlapping, s orbital overlapping. तो ये three head on head overlapping ये तो end to end overlap होगी sigma bond formation. Here first one is ss overlapping. In this case there is overlap of two half-filled s orbital along the internuclear axis. तो internuclear axis पे two s orbitals रहेगा, एक दूसरे के साथ overlap होगी sigma bond formation करेगी. Here s orbital, another s orbital having half-filled electron. Half-filled means one electron रहेगा, दोनों orbital overlap होगा तो pair of electron form. And next one is this one is sigma bond related. sp also क्योंकि s orbital shape is spherical shape, one s orbital Another one is orbital. Then these two orbitals means S is overlapping. S is overlapping. And next one is SP overlap. SP overlapping one is orbital and second one is P orbital. P orbital shape is double shape. यहाँ पे डबल शेप रहेगा एक दूसरे के साथ दोनों ऑर्बिटल ओवरलैप हो सकते हैं ओवरलैप होके एक ऑर्बिटल का साइज मैक्सिमम रहेगा मतलब इसको डायरेक्ट ऐसे ऑर्बिटल this one is sp orbital this one is p orbital this one is s orbital s is overlapping sigma 1 sp so head to head overlapping. Next one is PP orbital. PP overlapping the one orbital of P orbital and another one also P orbital terminal shape. तो ये दोनों एक टू एक ओवरलैप होते हैं यहाँ पे इलेक्ट्रॉन पेयर हो इस यहाँ पे ऐसा रहेगा ये मैक्सिमम ये दोनों ऑर्बिटल ओवरलैप. So these three overlaps will form sigma bond overlap. Sigma bond end to end overlap तो जिस होता है internuclear axis perpendicular भी रहेगा सॉरी इंटरन्यूक्लियर जो एक्सिस पे रहेगा वही एक्सिस पे रहता है एक्सिस ओवरलैपिंग भी होता है तो एसएस ओवरलैपिंग एसपी ओवरलैपिंग पीपी ओवरलैपिंग तो 3 एंड टू एंड होता है तो एंड टू एंड होगा तो सिग्मा बॉन्ड फॉर्म होने के चांसेस है. एंड नेक्स्ट वन इज pi bond quite opposite to the sigma bond का फॉर्म होता है एंड टू एंड ओवरलैप होगा तो सिग्मा बॉन्ड फॉर्म बट pi bond is formed by the overlapping of orbital side to side होगा और in the formation of pi bond the atomic orbitals overlap in such a way that their axis remains parallel to each other and perpendicular to the internuclear axis. यहाँ पे parallel to the internuclear axis यहाँ पे क्या होगा perpendicular to the internuclear axis. The orbital formed due to sidewise overlapping consists of two orbitals. तो यहाँ पे क्या होता है साइड टू साइड ओवरलैप होकर pi bond फॉर्म होता है. तो यहाँ पे क्या होता है इंटरन्यूक्लियर एक्सिस पैरेलल है यहाँ पे परपेंडिकुलर है तो यहाँ पे ऑलवेज s ऑर्बिटल फॉर्म्स सिग्मा बॉन्ड ओनली. s ऑर्बिटल कोई भी ऑर्बिटल के साथ ओवरलैप होने तो सिग्मा बॉन्ड फॉर्म होगा बट p ऑर्बिटल ओनली फॉर्म्स सिग्मा एंड pi bond. p एंड टू एंड ओवरलैप होगा तो सिग्मा बॉन्ड फॉर्म होगा p ऑर्बिटल साइड टू साइड ओवरलैप होगा तो pi bond. This one is one p orbital and this one is another one p orbital and these two orbitals side to side overlap होगा तो यहाँ पे क्या होता है pi bond फॉर्म होने की चांसेस side to side overlap pi bond फॉर्म होगा. This pi bond is p pi bond. Next, the strength of this sigma and pi bond. Sigma and pi bond strength. Which bond is more stable? Here, sigma bond is more stable than pi bond. Sigma bond is stronger one, end to end with the internuclear axis पे ही रहेगा तो attraction power ये bonding electron pair पे ज़्यादा रहेगा तो sigma bond is more stable than pi bond. तो pi bond weaker bond, sigma bond is stronger bond. sigma bond को break करने के लिए ज़्यादा energy requirement होता है pi bond को break करने के लिए less amount of energy required. Next topic is hybridization. Hybridization one of the important topic. Hybridization only decides the geometry of the molecule. इसलिए यहाँ पर क्या होगा chemical bonding complete हुआ. Next molecular structure. This molecular structure will depend on the hybridization of orbital of the central atom in the molecule. तो यहाँ पे ऑब्जर्व करो hybridization geometry VBT explains mainly this hybridization only. Based on hybridization molecular geometry will be decided. Here hybridization means different energy level orbitals. तो ये ऑब्जर्व करो केमिकल बॉन्डिंग में ऑलवेज वैलेंस इलेक्ट्रॉन्स वैलेंस ऑर्बिटल्स ही पार्टिसिपेट करें inner orbitals, inner electrons participate. So here hybridization means different energy level orbitals will combine and form equivalent energy level orbitals. Means different energy level orbital equally are combined with the same energy level orbital formation. This formation or this process is known as hybridization. Different energy level orbitals will mix and form same energy level orbitals. That is the process is known as hybridization. Here, in order to explain the characteristic geometrical shapes of polyatomic molecules to explain here, like CH4, methane, ammonia, and water, etc. Pauling introduced the concept of hybridization. According to him, the atomic orbitals combine to form a new set of equivalent orbitals known as hybrid orbitals. Equivalent orbitals known as hybrid orbitals. Hybrid orbitals. Hybrid orbital means after combination. हाइब्रिडाइजेशन की वजह से क्या होता है डिफरेंट एनर्जी लेवल ऑर्बिटल का एनर्जी सेम होता है आफ्टर हाइब्रिडाइजेशन तो आफ्टर हाइब्रिडाइजेशन the newly formed equivalent orbitals are known as hybrid orbitals. And next one, unlike pure orbitals, the phenomena is known as hybridization, which can be defined as the process of the intermixing of the orbitals of slightly different energy so as to redistribute their energies, resulting in the formation of new set of orbitals of equivalent energies and shape. For example, when 2s etc. Okay. So यहाँ पे minimum different energy level orbitals will combine and form new orbitals of equivalent energy. This process of this phenomenon is known as hybridization. After hybridization, the formed orbitals are known as hybrid orbitals. These hybrid orbitals will maintain maximum between orbitals. Hybrid orbitals maximum distance maintain करेगा. Reason ये है हाइब्रिड ऑर्बिटल्स में इलेक्ट्रॉन्स प्रेजेंट होगा इलेक्ट्रॉन की वजह से रिपल्शन रहेगा रिपल्शन की वजह से ऑर्बिटल स्प्लिट होके minimum means particular bond angle को maintain करेगा. Based on this bond angle, the geometry of the molecule will be decided. Here, hybridization, for example, one s orbital and three p orbitals. This three p orbitals, one s orbital. S, P orbitals are different energy level orbitals because S is nearest to the nucleus, lower energy level orbital. न्यूक्लियस से दूर रहेगा हायर एनर्जी लेवल ऑर्बिटल. तो यहाँ पे हायर एनर्जी लेवल ऑर्बिटल्स 3 होता है Px, Py, Pz, then only one R. ये दोनों सेम है मींस सेम n वैल्यू प्रिंसिपल क्वांटम नंबर सिमिलर और लेस एनर्जी डिफरेंट रहेगा. तो दिस फोर ऑर्बिटल्स विल कंबाइन एंड फॉर्म फोर न्यू इक्विवेलेंट एनर्जी ऑर्बिटल्स. तो यहाँ पे क्या होता है वन s ऑर्बिटल with 3 orbitals एक दूसरे के साथ कंबाइन होते हैं 4 orbital of energy equal to. These are the hybrid orbitals. Here these 4 orbitals are hybrid orbitals. These 4 hybrid orbitals having similar energy. Here the hybridization occurred between these 2 orbitals. One s orbital participated and 3 p orbitals participated. That's why the hybridization of this is sp3 hybridization. sp3 that means one s orbital hybridization में participate किया 3 p orbitals hybridization में participate किया. तो यहाँ पे एनर्जी लेवल सेम है बट डिफरेंट एनर्जी minimum energy will be different. That's when these 4 orbitals will combine and form same energy level orbitals. This process is known as hybridization, and these 4 orbitals are known as hybrid orbitals. Hybridization is sp3 hybridization will occur these 2 orbitals. And the silent features of the hybridization. So hybridization rule ये है compulsory valency orbitals only participated in the hybridization and number of atomic orbitals will be participated in the hybridization and that number equal to hybrid orbitals. Atomic orbital जितना hybridization में participate करेगा उतना ही hybrid orbitals form होगा ज़्यादा कम नहीं form होगा. Clear? And next hybrid orbitals will split and maintain minimum distance between hybrid orbitals. That's why particular geometry will be obtained to the molecule by the hybrid orbitals only. तो जितना ऑर्बिटल्स वैलेंसी ऑर्बिटल्स पार्टिसिपेट करते हैं, जितना ऑर्बिटल एटॉमिक ऑर्बिटल फॉर्म होगा उतना टोटल नंबर ऑफ हाइब्रिड ऑर्बिटल्स इक्वल रहेगा. एंड hybrid orbitals only forms particular geometry to the molecule. And here next one, important conditions for hybridization. The orbitals present in the valence shell of the atom are hybridized compulsory. Next, the orbitals undergoing hybridization should be have most equal energy. तो मिनिमम एनर्जी लेवल डिफरेंस होना चाहिए. ज़्यादा एनर्जी डिफरेंस होगा तो मतलब यहाँ पे एन वैल्यू डिफरेंट होगा तो एनर्जी लेवल मैक्सिमम डिफरेंस होगा. So minimum energy level orbitals only will participate in the hybridization. And next one, the promotion of electron is not essential condition for prior to hybridization. Electron का जरूरत नहीं रहेगा, वैलेंसी ऑर्बिटल का इंपॉर्टेंट होते हैं. It is not necessary that only half-filled orbitals. तो half-filled orbitals only hybridization का रूल नहीं है. Full-filled orbital also participate in hybridization. Full-filled होगा तो भी hybridization में participate कर सकते हैं. Half-filled होगा तो भी hybridization में participate कर सकते हैं. These are the conditions of the hybridization. And next one, types of hybridization. तो ये hybridization का rules है. Hybridization is very important in chemistry, and this hybridization is one of the most important for the organic compounds. Organic compounds के लिए hybridization ज़्यादा important है, ध्यान रखो. Hybridization means different energy level orbitals will combine and form same energy level orbitals. Different means minimum energy different orbitals will combine and form same energy level orbital. This phenomena is known as hybridization. Hybridization के लिए rules ये हैं, वैलेंसी ऑर्बिटल से रहेगा, 1 इलेक्ट्रॉन होने दो, 2 इलेक्ट्रॉन होने दो, हाइब्रिडेशन में पार्टिसिपेट कर सकते हैं. मिनिमम एनर्जी डिफरेंट ऑर्बिटल्स only will combine and form, and these orbitals only form the geometry to the molecule. And next, types of hybridization. Types of hybridization. Here there are depend on the orbital hybridization also different types. Here there are various type of hybridization involving with s orbital, p orbital, and d orbital. The different type of hybridization are as under. First one is sp hybridization. Sp hybridization. sp hybridization simple. इसमें क्या होगा, 1 s orbital 1 p orbital will combine and form sp hybridization. So here only 2 orbitals will overlap and form 2 hybrid orbitals and formation of sp hybridization. तो यहाँ पे हम लोग sp hybridization में क्या करना है, एग्जाम्पल ऑब्जर्व करना है. एग्जाम्पल ऑब्जर्व करने के लिए orbital proportion भी ऑब्जर्व करो. sp hybridization में s orbital participation is 50% and p orbital also participation is 50%. 50 plus 100% means here 2 orbitals proportion is 50-50. Example for this sp hybridization is beryllium fluoride according to old textbook. Example of molecule having sp hybridization. One is beryllium fluoride and only beryllium fluoride is given. Organic molecule इथाइन मॉलिक्यूल भी लिख सकते हैं. तो यहाँ पे बेरिलियम क्लोराइड है, वही यहाँ पे एक्सप्लेन करूँगा ध्यान से. बेरिलियम क्लोराइड hybridization, geometry, bond angle, electronic configuration, atomic number are very important to write the hybridization of the molecules. So here central atom maximum Lewis dot representation ये करना है. Central atom electropositive element रहेगा, around the molecules are higher electronegative atoms. Here beryllium is central atom. Beryllium atomic number is 4. Electron configuration is 1s2 2s2. 1s2 2s2 is electronic configuration. This electronic configuration is ground state electronic configuration. So ground state होगा तो next start होने वाला और करेंगे जब 2p 0 भी लिख सकते हैं ऑलरेडी फर्स्ट शेल सेकंड शेल में 2p 0 हो सकता है, there is no electrons, that's why this is ground state electronic configuration. When we apply some energy, then this electron will be jumped into this into the 2p orbital, then 2s1 2p1 option. So this electronic configuration state of beryllium is known as excited state of electronic configuration. Excited, but some energy will be supplied to this molecule. When the second electron will be jumped into the p orbital. Total number of electrons 48, but electron को jump किया क्योंकि p orbital को participation करना है. One electron representation of electrons in the orbital having one electron only. And here we are going to discuss the hybridization of sp hybridization. So here we need two orbitals, one is s orbital and second one is p orbital. These two are same energy level orbitals. Energy level दोनों का same है, n value same. Second, this is the valency shell. Here valency shell, s orbital having one electron, p orbital having one electron. These two are the same energy level orbitals, but these two having minimum energy difference orbitals because that is s orbital, another one is p orbital. The energy level orbitals order is s is more stable than p is more stable than d is more stable than f because nearest to the nucleus farthest from the nucleus. That's why here s orbital having lower energy level orbital, p orbital having minimum higher energy level orbital than s. Means in these two orbital energy difference is minimum, but we need similar energy to form the similar energy to this orbital. What will happen then? Hybridization will occur these two orbital. ये दोनों ऑर्बिटल के बीच में क्या होगा? हाइब्रिडेशन. Means different energy level orbitals will combine and form same energy level orbital. रूल ये है हाइब्रिडेशन में एटॉमिक ऑर्बिटल जितना पार्टिसिपेट करेगा उतना ही हाइब्रिड ऑर्बिटल्स फॉर्म होंगे. Only two hybrid orbitals will be formed because one and one s orbital, one p orbital will be hybridized, and these two orbitals having one electron. Here hybridization will occur sp hybridization. यहाँ पे जो हाइब्रिडेशन होगा वो sp हाइब्रिडेशन होगा. इलेक्ट्रॉन क्लॉकवाइज डायरेक्शन में और 7 नहीं होगा. क्लॉक तो ऐसे लिख सकते हैं, नो प्रॉब्लम. Okay, so two electrons हैं, so these two are hybrid orbitals and these two orbitals having same energy equivalent orbitals, and hybridization is sp hybridization because in this hybridization one s orbital will be participated and another p also will be participated. One p orbital, one s orbital. That's why this is known as sp hybridization. तो ये बेरिलियम एटम में सेंट्रल एटम बेरिलियम एटम में टू ऑर्बिटल एक दूसरे के साथ स्प्लिट होगा क्योंकि रिपल्शन होगा बिकॉज दिस टू ऑर्बिटल हैविंग वन इलेक्ट्रॉन. तो ये वन इलेक्ट्रॉन की वजह से दोनों के बीच में क्या होता है? रिपल्शन होगा. रिपल्शन होकर ऑर्बिटल स्प्लिट होकर टू ऑर्बिटल्स एट द सेंट्रल एटम 180 डिग्री डिस्टेंस पे मेंटेन. बेरिलियम one electron and another one electron. The bond angle between bonding orbital is 180 degrees. So sp होगा तो there is no load में already last class में discuss किया 180 degrees. ये hybrid orbital sp hybrid orbital. This hybrid orbital overlap with the orbital of chlorine. Chlorine atomic number is 17. यहाँ पर लिखता हूँ क्लोरीन atomic number 17. Electronic configuration 1s2 2s2 2p6 3s2 3p5. This is the valency shell. Okay, the valency shell s orbital having 2 electrons, p orbital having 5 electrons. Okay, this 2pz orbital overlap with the hybrid orbital of beryllium. यहाँ पे क्लोरीन का 3pz orbital overlap होके one pair form हो गया. Similarly, another chlorine another electron. This one is 3 is the orbital of chlorine. तो यहाँ पे एक बॉन्ड फॉर्म होगा, यहाँ पे एक बॉन्ड फॉर्म होगा, दैट मींस बेरिलियम क्लोरीन क्लोरीन, द बॉन्ड एंगल इज 180 डिग्रीज। तो यहाँ पे पूरा ये आर्कल पूरा स्ट्रेट लाइन पे है, तो ये हाइब्रिड आर्कल स्ट्रेट लाइन होगा तो बॉन्ड एंगल 180 डिग्रीज रहेगा। बॉन्ड एंगल 180 डिग्रीज होगा तो ज्योमेट्री इज linear geometry in molecule. Means by the hybridization we can find the geometry answer. In case molecular hybridization is sp without lone pair, then geometry is linear, bond angle is 180 degrees. And next one is hybridization is sp3 hybridization. Simple. Sp complete. Sp2 also is there, sp2, sp3, etc. But okay, next hybridization is sp2. sp hybridization completed. Next sp2 hybridization. sp2 hybridization का example check करना है बस. Hybridization is sp. In this sp2 hybridization, one s orbital, two p orbitals participate करेंगे. तो one s orbital, two p orbital एक दूसरे के साथ ओवरलैप होकर hybrid orbitals फॉर्म होगा. 3 hybrid orbitals मिनिमम डिस्टेंस में रिपल्शन होगा, डिस्टेंस मेंटेन करेंगे, बॉन्ड एंगल 120 डिग्रीज रहेगा विदाउट लोन पेयर, देन ज्योमेट्री इज ट्राइगोनल प्लेनर. एग्जांपल बोरान ट्राइक्लोराइड, बोरान PCl central atom body, boron 5 1s2 2s2 2p 1 excited state electronic configuration 2s2 2s1 2p2. This one is excited state of electronic configuration. But here sp2 ऑर्बिटल डिस्कशन कर रहे हैं, दोनों से ऑर्बिटल 2p ऑर्बिटल एक दूसरे के साथ ओवरलैप हुआ, 3 similar energy level orbitals form होगा. This hybridization is known as sp2 hybridization. sp2 hybridization होगा तो लोन पेयर होगा तो according to valence chain electron pair repulsion theory. Without lone pair sp2 hybridization, the bond angle is 120 degrees. Geometry is trigonal planar geometry. 120 डिग्री बॉन्ड एंगल रहेगा, ये आर्बिटल के बीच में 120 डिग्री बॉन्ड एंगल रहेगा, ट्राइगोनल प्लेनर ज्योमेट्री में होता है. Here boron central atom is boron. st orbitals are arranged trigonal planar because 120 degree bond angle 1 2 and 3. Here the bond angle is 120 degrees. These 3 hybrid orbitals are having 1 electron. sp2 hybrid orbital, sp2 hybrid orbital, sp2 hybrid orbital. These 3 hybrid orbitals with overlap chlorine orbital of 3 pz. अभी सेम पहले जो एक्सप्लेन किया था वही इसके जैसे रहेगा, 3 pz orbital रहेगा. One electron and another one is same, one electron here, an electron. Trigonal planar geometry. sp2 120 degrees and trigonal planar geometry for this molecule. This is the hybridization. तो यहाँ पे जो hybridization हुआ all are sigma bonds, 3 sigma bonds form. Hybrid orbitals always form sigma bond only. Non-hybrid orbitals only forms pi bond. ये fix. Hybrid orbitals sigma bond form होता है. तो including lone pair होगा तो भी it is also including sigma bond only because it is also 2 electron containing orbital also participated in hybridization. That's why it is also equal to sigma bond. Means double bonded 2 electron containing orbital होने दो, all sigma bonded orbitals होने दो, hybridization participate. Means all hybridized orbitals are belongs to the sigma bonded orbitals. जितना orbital hybrid होता है hybridization होता है वो सब sigma bond में calculate करना पड़ेगा. Alright, this is the geometry of BCl3 boron trichloride. Example for sp2, one chlorine, another chlorine, another chlorine, 3 chlorines, triangular planar geometry. The next one, example for sp3 hybridization. sp3 hybridization, sp3 hybridization, one s orbital, 3p orbital. Example, CH3, CH4 molecule, मीथेन molecule, H2O molecule and H3 molecule. तो इसमें जब बहुत डिफरेंस है. Methane there is no lone pair of electron, but ammonia having one lone pair of electron, H2O having two lone pair of electrons. Ammonia H2O participated in sp3 hybridization, but geometries are different. Methane also participated in sp3 hybridization. There is no lone pair. Tetrahedral geometry 109.5 degrees bond angle. But these two molecules having H2 and ammonia having one pair lone pair of electrons, one lone pair of ammonia, two lone pair water, then bond angle will be changed and geometry also changed according to valence shell electron pair repulsion theory. Okay. Next we will discuss sp3 ablation and examples for ablation. Here this topic is very important. This is belongs to the VBT valency bond theory में include होता है. So what is ablation? Types of ablation and bond types of bonds also important. Based on overlapping of orbital, covalent bond orbital, covalent bond is two types. One is sigma bond, pi bond. Sigma bond is more stronger than pi bond. And hybridization, types of hybridization, sp hybridization completed, sp2 completed. Next sp3 we will discuss another class.